Hello and welcome to my channel, Cyber Hero. What we are going to discuss, this will be the first video of my series of Linux. You guys have clicked here. You are most welcome. Here we will discuss about Linux. The first chapter is our Introduction to Linux. Here we will overview of operating systems. What is operating system? What is its definition? What are its functions? We will see all these points. But we will not go in depth, because if we will go in depth, maybe we will feel bored. It's like that. So in upcoming videos, we will go for depth of what is that. So starting with the definition of an OS. What is an OS? An operating system is a system software that manages hardware and software resources and provides a service to application and users. A simple definition, as you can say, software that manages hardware and software resources. Nothing special. So, what are the functions of OS? Here, some pointers are here written: process management, memory management, file management, device management, and security networking. These are the main functions of OS. What does the process management mean, memory management mean, file management mean, device and security networking? In depth we are not going to discuss that, but I will give an overview of these functions. First, process management. This is the heart of modern operating system. This is the heart of modern operating systems. Let me write here, heart of modern operating system. What does it do? A process is a program in execution. What is process? Someone tell you what is process? A process is a program under execution. Clear. Some main points are here about this process management, like process scheduling. If you are aware about this term, have you heard this? Process scheduling. Clear. Scheduling. Sorry. Then what is another term for scheduling? I heard. Then another thing is here, process creation and termination. Process creation and termination. Another thing is IPC. The full form of IPC is inter-process communication. So, let's understand these terms first. The OS decides which process gets to use CPU and for how long. It uses algorithms like round robin, priority scheduling to ensure fair and efficient CPU utilization. It's all decided by the OS. Hope so you are clear. If you want a depth video, what does that mean? Show us some practical examples. Just tell me in a comment section, I will go then for that. Hope you got this one. Then another is memory management. What is in memory management? The OS manages the computer's primary memory. What is that? RAM, which is a critical and limited resource. You know that for an PC, mobile, etc. there is a RAM which is in limited amount, for a 4 GB RAM, 8 GB RAM, 12 GB RAM, like that. So it is very hard to manage that. It is a very fast memory. So it is handled by the OS only. Then memory management is a different topic, it's a vast topic. If you want for that, just inform me in a comment section. Then file management, device management, security and networking. Some points about file management. What are the file management points? Here we will go file creation and deletion. I create a file and I deleted a file. It's all about handled by the OS. Access permission, access permission, access permission. Then storage allocation, that's it. Then device management, yani input output management. Some device drivers, buffering and caching, allocation and scheduling. These are main subheadings which comes under this topic. Device management. It's also a different topic. We'll not go in a depth. We are just here for an overview of this topic. Then security and access control. Some subheadings also comes here. Let me write here this. User authentication. Then authorization, protection. So what does that user authentication means, authorization means, protection means? We'll discuss them later. Here we are just for over. Hope so you guys understand this. Types of OS. Types of OS: batch OS, time sharing OS, distributed OS, network OS, real-time OS. We'll make a different video of types of OS where I will discuss them with an example. What are batch OSs, time sharing OSs, right? Now just overviewing at now chapter 2, history and evolution of Linux. Here we will overview this. Definition: Linux is an open source operating system. Linux is an open source operating system. Kernel created by, inspired by Unix and GNU tools. So, if you know some history and evolution of Linux, that is good. If you don't know, then it's also good. I am here. Simply just remember one point, that's the main thing about it. Linux is an open source operating system. What does that mean, open source operating system? Right. Open source operating system means that use here. I will clear you with this. Open source operating system. Operating system. Open source operating system are the software platforms whose source code is freely available for anyone to view, modify, and distribute. They are ideal for customization, learning, building secure, transparent systems. Here are some most popular and powerful ones. Linux-based operating systems. Ubuntu, Debian. If you are using them, it's good. If you are not using them, it's also good. Here we will, in upcoming later videos, we will download them. We will see how they are user friendly and so on. What are these features? Some non-Linux open source OS is FreeBSD, OpenBSD, React OS. So I hope now you are clear about what is open source operating system. Got this? Good. Then Linux architecture, the main thing. What are the components of Linux? Here we say the kernel, shell, file system, utilities. What is a kernel? What is a shell? Right. What is a kernel? Kernel is a core of operating system. What is a kernel? It's a core of operating system in a single. It's a single and large program that contains all the essential code to manage hardware, process, memory, etc. Hope so you got this. It's a core of operating system. It's single large program, right? It is a single large program written that contains all essential code to manage hardware, process, memory, etc. Its key jobs are. Let's see what it do actually. Process management. First we discuss that now. Process management, memory management, files. It's all handled by the kernel. So you got now concept about. Don't worry about you are not understanding these terms. These are new to you. No worries. We'll discuss them in depth in upcoming videos. No worries. So kernel shell, it's command line interpreter, just like a CMD. I will open here CMD, that's called the shell. It's a command line interpreter, just like bash, zsh. It's for Linux. Some file system hierarchical organization of files, where we create directories, folders, files. It's just like in RAID, where we create a folder, then inside a folder we create another folder like that. This is called a hierarchical organization of files. Then utilities, tools and command, we'll discuss them later. No, don't worry about that. Here is an overview. I can repeat. Some kernel type is monolithic. This entire OS in a one kernel. I hope you got this by point. Not, no worries. This is just an word. Micro hybrid. Let's see go. We'll show you architecture of Linux. If you are preparing for any exam, this diagram will help you definitely. How architecture of Linux OS. Applications, shell, kernel, hardware. Kernel is a system which interacts with hardware. Then it goes for shell, then it goes to application. For example, in a kernel, some printer desks are here. Let me tell you one thing, just taking an example of mouse. My mouse is in hardware. It's connected to my laptop by, it's a whole, what we can say, handled by, which is by kernel. Then I press here, for example, then kernel send a message. Again, where I click, the application will open like that. So then we'll go for working of these things in a depth. Don't worry about that. This is an overview of architecture of Linux OS. Hope so. Then another thing is there. User space versus kernel space. Important topic. In user space, applications run here safely and isolated. I opened it Google, then I opened this PDF format. It's all about, they are run separately, isolation. There is no touch between that image and this PDF. They are running separately. These are whole managed by the user space. Another thing is there, kernel space. Direct hardware interaction. What I was discussing before some minutes, that my mouse is connected to my PC. It's all about managed by the kernel space. Some system calls, this is an important topic. We'll go for that in later upcoming videos. Let me show you some diagram, this user space and kernel space. This is user space, where user application and GNC library, system call interface, kernel, hardware platform. So architecture different kernel code, just at if you have heard about system architecture 64-bit, 32-bit, if you are not aware of that, for every system, it may be a 32-bit, it may be a 64-bit. You can check it by see in your system settings how many bit it is. In kernel system call interface, this is a very important topic. We'll go in depth. We'll see how it works with an example later on. So let's discuss what we have studied, what we'll try to understand in this video. First we'll go for that OS definition. I design OS, then OS functions. Linux history fellow, just simply Linux history fellow, how it comes. First it was a Unix, then in 1991 it becomes Linux. It was actually that inspired from that. Then Linux architecture components were where we say that kernel, shell, utilities, say kernel types. Simply we go for definition of system. We didn't go in depth. Then I hope this overview has over now. Hope you guys like the videos. If you didn't understand anything, don't worry. In upcoming later videos, I will make it clear to you. In every point, we will go for depth. No worries. Just like and videos so I will get motivated for other videos. Thank you. Thank you guys. Bye bye. Take care. See you in next video.